It is my greatest pleasure to welcome you to our CISLL Keynote session and to introduce our distinguished speaker, Dr. Lisa Goffman. Dr. Goffman is a senior scientist and the Mary Pat Moeller Chair of Child Language at the Center for Childhood Deafness, Language and Learning at Boys Town National Research Hospital. Before embarking on her research career, she worked as a speech-language pathologist in a transdisciplinary early intervention program, an experience that continues to inform her deeply impactful and clinically grounded work today. The central aim of Dr. Goffman's research is to develop a comprehensive account of developmental language disorder, one that bridges insights from shared motor and cognitive processes with the development of effective assessment and intervention practices. Her work has been continuously funded by the National Institutes of Health, particularly the National Institute on Deafness and Other Communication Disorders, an indicator not only of her research's rigor, but its enduring significance to our field. On a personal note, I am especially thrilled to welcome Dr. Goffman to campus today. I had the privilege of working with her for 7 years at Purdue University, where she was my master's thesis advisor and my PhD mentor. I can personally attest not only to her brilliance as a scientist, but also to her extraordinary dedication as a mentor. Dr. Goffman was always thoughtful and generous with her time and deeply committed to the success and growth of her students. Today, Dr. Goffman will present her keynote address titled Developmental Language Disorder as a Complex Neurodevelopmental Diagnostic Category. This talk promises to offer important insights on how we conceptualize developmental language disorder and how those perspectives can shape both research and practice. Please join me in warmly welcoming Dr. Lisa Goffman.
I'm so thrilled to be here today. I've actually had the privilege myself, of working with Allison for many years now, but of also working with your center here, and I have been extraordinarily impressed. I think you are doing exactly the kind of work to get out of our silos and to cross disciplinary boundaries that is very, very much needed. It has been a goal of my career to cross some boundaries that I hope I can share with you today, but the work going on here is really extraordinary, and I'm thrilled to be talking with you today. So I first need to thank members of my lab, as well as Allison mentioned, the support of the NIDCD. We call ourselves the Language and Motion Lab, and you will see why. I'm going to dive right in because I have a lot to say today. We're going to talk about a lot of different topics. I'm going to start with talking about the disorder that I predominantly, but not exclusively, study, which is called developmental language disorder, and why I think this is an important disorder to understand. I'm going to talk about the importance of co-occurrences or comorbidities in DLD. We've talked about math, we talk about literacy, a lot of the issues in your center I think all require attention when we're thinking about these children who are defined formally by their language problems. I have focused my career on a very specific co-occurrence, which is how language, speech, and motor domains interact in DLD. I'm just trying to kind of give you a roadmap because honestly, I'm kind of all over the place in a lot of ways. So hopefully this will help. I'm going to talk then about evidence for and against a manual motor deficit in DLD and for and against a speech motor deficit. And then I'm going to land on what I'm going to describe as a more mechanistic explanation that underpins all of these areas of deficit, which is in sequential pattern learning. I'm going to mention, but not talk about in great detail, that we are now positioning these interactions that we're seeing into typical developmental theory. So that's where we're going to head today. So I'm going to start with talking about what is DLD, which is also often known as specific language impairment, or SLI. I'm making a very strong case today, and others will join me that it's not that specific. These are children with normal intelligence, and I'm going to say relatively normal motor and social interactive skills, because I'm then going to make the case that they have motor problems, and normal hearing who show significant difficulties with language. I think the underlying point is motor skills, hearing skills, they don't have autism, none of these features define their problems with language. As we've moved into this, and Allison's work has informed this, People with autism may or may not have language problems. People with hearing loss may or may not have language problems. So there are some flaws in our approach, but this is the kind of formal definition that the field has worked from. DLD is often diagnosed when kids are around 4, and these are some sample utterances that a child may say. Things like, him keep falling, it go this way, they all grown up. And what I hope you can note is this child's having problems with grammar. They're expressing pretty complicated ideas. There are a lot of grammatical errors that if you don't know, you wouldn't expect in a 4-year-old. The other point, though, so this is what we have talked about and what has defined DLD or SLI, but it turns out DLD extends across the lifespan and has many additional features that are kind of unfolding as our science progresses. This is just a little picture of what has classically been the major areas of deficit in DLD, which are grammatical problems, which I showed you, and also sound patterns or phonological problems. So these are the kinds of problems that have really classically been identified in DLD. I kind of use orange to say areas of problem, and then areas that are not really problems. And I'm going to say things like words or the lexicon, articulation, and concepts are not necessarily problems for these kids. But it's, again, a complicated story, so keep your eyes on it. I like a little public service moment. Why does it matter? Why do we care if kids have DLD or not? It affects a lot of kids. I'm going to say closer to 7, but some people report as many as 14% of 5-year-old children. And as I mentioned, their long-term outcomes are often poor: academic, family, psychosocial. They have a lot of long-standing difficulties. They're often identified late, and I'm going to say if at all, when some of these overt grammatical problems that I showed you, like at 4, 5, or even 6, become obvious. And we know that we need to intervene earlier, that, babies are a lot more flexible than 15-year-olds, sad to say. So this is a real problem. Also, treatments are often slow and laborious. We really don't have extremely effective treatments for these kids. And we have really made the strong case that these children are understudied and underserved. We recently published a paper, and Allison asked me to bring this in, and I think it really fits in a fun way. The way I've talked about DLD, how do we diagnose this? It's often what we call categorical. So we give a set of tests and a cutoff score, usually in grammar and topics like that. Children on one side of the cutoff have DLD, and on the other side, they don't have DLD. So that's a really categorical sort of diagnosis. And DLD is defined as children with difficulties in learning, comprehending, and expressing language, whether spoken, written, or signed. I've mentioned these people often go undiagnosed, and I'm going to say phenotypic variation is expected. What I mean by that is there's a lot of heterogeneity in these people. They may have motor problems, speech problems, and then also developmental change. So we can't just say, here's a nice measure of grammar, and this will define DLD. We cannot do that. So the spectral model that we're putting forth is multidimensional and overlaps with many other neurodevelopmental conditions, such as attention deficit and hyperactivity disorder, motor disorder, which is also developmental coordination disorder, and dyslexia. However, in this account, sometimes these overlaps are just viewed as noise. They're not mechanistically related to the disorder. And we are making the argument that specific deficits in procedural and sequential pattern learning would affect both language and motor skill. And I think that has real implications for assessment. I think it has real implications for intervention that hopefully will emerge in the context of the talk. So I'm actually going to show you just a minute of a video of a person with DLD so that you can get a sense of what this is like. Basically, there's a website that my colleague at Boys Town, Carla McGregor, has really taken a lead on called DLD and Me. So if you're interested in this, go to that website. But I just want to show you a young college-age person with DLD to give you a sense of, yeah, I'll make it big.
I was a very quiet kid, so I remember I tried to talk like my father. He also, I say, speaks funny, but maybe that's just because now I'm hindsight 2020 and play some, but I think there was, like I'll say, I don't know. Sorry, I'm just trying to form my words. Like, I think it was definitely there. It's just no one around me really paid attention, if that makes sense. So, especially in a small town, there's not really a lot of resources for these disorders, basically. There's no SLP or anything like that. So, yeah, I do think it was there. I just think it wasn't really explored. The classic example is like kids will grow out of it, like they'll mature out of it, which it's not true. When I first came into I very became aware of it was probably in high school. I put in assignments and everything would be correct, like they'd say this is a perfect essay, whatever. But I would lose marks all the time for my grammar errors. So I'd have to call my mom and be like, hey, what's this? Like, I know the word, but I don't know the word.
Okay, and that gives you a sense. Go to the website if you want to see more of these and more of him. So what I think Grant's story highlights is several aspects of DLD. It's not identified and thus not treated. It's lifespan. He's a college student. There's a family history. He talked about his dad. He has language difficulties. And I would make the case he also has some speech articulation difficulties. In our work, following from this example, I think, we have really talked about, of course, defining DLD as a language disorder, but the idea that speech and even manual motor skill are also affected. We have made the argument that analysis of action, speech and manual, contribute centrally to accounts of typical and atypical language development. We're not alone in this thinking. There's a scientist, Jana Iverson, who studies toddlers, and she also studies autism and how motor skill interacts with language skill. When you learn to walk, you experience the world in new ways, you learn new words. People think along these lines. We have really pulled this in to explaining DLD and potentially the interventions that might follow, and we make the argument that these really change when studied through the lens of speech production and action. Now, I'm going to show you a complicated little model. We're just going to use it to make a point here. So this is Levelt's language production model. This is comprehension, this is production. And these are the kinds of models people use to think about language. So when we say something, we conceptualize that message, we turn it into grammar, we turn it into sound patterns, we map it to words, and then we articulate it, we produce it. So articulation is here, this tiny little box at the end of this. Levelt didn't really care about articulation. This is a map from Frank Gunther, the DIVA model. All I want you to notice from this is just articulation. Feed-forward control, speech-sound map, somatosensory targets, auditory targets. Language isn't even on this map. And we see this as a problem in the field, that people are just not conceptually linking these levels. So we make the argument that there's much evidence for interactivity and that many language and action tasks obligate sequential processing. When we produce a sentence, words are produced in a sequence, sounds are produced in a sequence, and the same is true of much manual action. Music is the one example I'm going to share with you today. So we think it's not at all surprising that comorbidities may be more than just random, but actually be really important for defining the deficit. So several researchers have made this claim that kids with DLD and adults with DLD demonstrate weak performance on a generalized test of motor skill. And we've even shown in our lab with another doctoral student Leah Sack, that if you measure motor, language, and speech skills at 4, kids with DLD at 4, motor problems actually predict their outcomes 2 years later better than language or speech skills at 4. So there's something important going on in the motor system. As I've alluded to, I think, one possibility is that the motor impairment associated with DLD is not mechanistically connected. That's kind of the spectrum account. But we don't actually support this account. We propose a framework for conceptualizing learning in children with DLD, which focuses on more domain general cognitive mechanisms that are central to the disorder, such as sequential pattern learning. Bishop and Sue, who are 2 researchers in the field, have also made some of the same claims, saying that children with DLD have particular problems in learning to recognize sequential patterns. This difficulty is evident even when no language is involved and could explain why children have such difficulties with learning grammatical constructions such as appropriate use of past tense endings. This work could help us identify the best conditions for teaching language skills. I've come to do very basic work kind of back to how we think about interventions and assessment. So because there are a lot of students in the room, I really like to talk about my own, I started as a clinician. That's actually where these ideas were born. Early on, our hypothesis in the lab was that children just with DLD have a generalized motor problem. We had no idea what it was. The data started to come in and we're like, wait, they don't always have a motor problem. They only have it in certain tasks. So that's when we started focusing on a more specified cognitive deficit, again in sequential learning, that affects multiple domains. We have focused on language and action, but if we're right, memory, other domains should be affected. So currently we're now, as I mentioned, positioning this into how babies and adults learn novel language sequences. But I'm going to focus a lot today on this middle hypothesis. To begin with then, I need to tell you how we measure speech motor and generalized motor skills. So we do what all language and speech scientists do. We write down what kids say. If they omit a sound or a word, we write that down. But we also do motion capture. And this is our old system. Allison has one in her lab. We have a new one now, which is a little less invasive. But we've run tons of kids on this system. The goggles are here to subtract out head movement so the kids can move. With all this complexity, all we're doing is tracking this little lower lip marker while it moves through time. So a classic sentence, some of you may have messed with this sentence even in labs here, is the sentence, "Buy Bobby a puppy." So you can see this little lower lip mark. This is just the motion of this marker. The lips are closed, they open, they close, they open. This is the syllable Bob. This is the syllable pup, okay? So I just want to orient you to the kind of signal that we use to look at speech motor skill. Our first findings showed that kids with DLD had a speech motor deficit. And I need to give you one more little methodological journey to explain this to you. So this is a child with DLD or SLI and a typical peer producing the sentence, "Bobby pushed the puppy." So these are those trajectories, and we have the child say it many times. So they're saying, "Bobby pushed the puppy, Bobby pushed the puppy." And so these are multiple overlying productions. And what we do is we don't care if they can be fast and slow. We care about their patterning of their movements. So if you draw a little circle and a big circle, they don't overlap. If you stretch the little circle, they're both patterned the same way if you're a good circle drawer. These are accurate productions, and we force them to the same time and amplitude scale, and we're interested in variability. I think you could tell by looking. This kid who's perfectly accurate is more variable than this kid who's typically developing. But we need a number because we do science. So we take slices at 2% intervals. We take the standard deviations of those slices. We sum those, and a bigger number, a bigger sum, is our index of variability. So 27 is a bigger number than 22. The kid with DLD is more variable. that's kind of the end of our heavy-duty method stuff, but you kind of have to make sense of that to make sense of what follows. So kids with DLD show deficits in speech motor skill, and we've shown this in study after study. They have a higher STI than their typical peers. They also show deficits in gross and fine motor skill. So they show weaker performance on the movement ABC, which is just a measure of gross and fine motor skill. So far, it seems like they just have this generalized deficit, but again, I'm now going to talk about why the story is more complex. So we're moving to evidence for a manual motor deficit in DLD, and I'm first going to talk about some evidence both against and for a manual motor deficit. I'm going to talk about tapping and clapping, and we're going to go through some manual tasks with clapping, signing, and music. So the first experiment is this idea that tapping is not affected in DLD, and you guys are, some of you are doing some work on this, so I chose it carefully. Metronomic timing variability, we know from prior work, is a signature of cerebellar problems, lesions. Adults with cerebellar lesions have difficulty with a metronomic timing task. So what you do is you tap or clap. We thought clapping would be easier, so we did both. You beep, 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 beep for 16 intervals, and then you carry it on for 32 more intervals. And our hypothesis was that kids with DLD should have cerebellar problems. Kids with dyslexia are thought to as well. They should have problems with this task. Well, this is clapping. This is what the motion capture looks like. Synchronization, continuation, and here are the data. We're just going to look at this side because it turns out the variability in the continuation interval is the marker of cerebellar problems. There are literally thousands of studies showing this. Kids with DLD had no problem. This is the DLD group, TD group, no significant difference. But when we asked them to clap, they had a problem. We're like, that's not what we expected. That's the beauty of science. So we made the inference that cerebellar timing is not affected based on these results. But the sequence coordination of two effectors, two hands, the motion of one hand is dependent on the other, was indeed affected. So we're like, oh, this is interesting. We better kind of dig into this a little more deeply. The story was getting more interesting. So I had to share this one. This is Dr. Gladfelter, who helped with this study, and you guys are analyzing some data from kids with autism right now. So we said, let's try a different kind of manual task that involves something a little closer to language. And we've been following up. We've done some other studies on this now. These are like iconic gestures or signs that we were teaching kids, and they just watch somebody do like empanada maker, apple corer, hamburger shaper, honeycomb spoon, very creative of us. We used hand shapes that were consistent with real sign language, but so it's kind of between gesture and sign. And the first thing we did is we measured accuracy of these in our kids with DLD using the measures that sign language researchers use. So the phonological features of signs are, do they get the hand shape right? Or are there errors? Do they get the path of movement right? Do they get the orientation of the hands right? Kids with DLD were actually surprisingly not as good at this. And we were a little surprised because those involved in intervention, we use gesture all the time. And believe me, I'm not saying you shouldn't. But I am saying some of these pattern learning components are also affected in gesture. Motion. So these are these STIs you now know how to look at. This to me shows you why normalization really matters. Look, these don't overlap at all, but when we normalize them, these are the motions for empanada. And I'm just kind of showing you what they look like, and we can do STIs on them, and we can look at the data. And the kids with DLD show higher STIs in dominant and non-dominant hands when the motion of the hands depend on one another, but not when the hands are moving together, even though the hand shapes are just as hard and they show errors in our other analysis. Does this remind you a little bit of the clapping data? There's something interesting going on here. So children with DLD actually show more phonological errors than their typical peers in the production of novel signs, which is, I'm going to show you in a little while, is exactly what we see in novel spoken word tasks. These kids, we're starting to say they don't have a generalized motor deficit. Only these signs or gestures that require coordinated manual action show difficulties in the motor system. One more example in the manual domain, and this is music. So we started thinking, okay, many people have argued that music is analogous to language. Both are basically hierarchical, sequential, that they have some of the same demands. And so we wanted to know if kids with DLD would have difficulties with reproducing really simple musical sequences. We actually have a bunch of sequences, and we now have some new data from older kids. They can produce more sequences, but we went to the literature. What musical sequences can 5-year-olds imitate? Our kids with DLD could only imitate this one. So this is what we studied at first. It was like, pause. This is what the motion looks like for that sequence. So remember before the metronomic timing task, these kids had no trouble at all. When we impose even the simplest structure that's more complex, they have trouble. So this is just a picture of a child producing boom, 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 pause, boom, boom, boom. It's well structured. This one, they're just all over the place. There are too many beats. The beats are not well organized, and this is what some of the kids with DLD were doing. In the group data, the children with DLD were more like 45% accurate in implementing these sequences, while the typical kids were more like 70% accurate. So that's a pretty whopping group difference. And the kids with DLD, this is just how variable were they from one instantiation to the next as they imitated these sequences. And the kids with DLD were also more variable. So we're like, I'm going to move to speech prosody in a minute, but prosody or grouping deficits seem to be domain general. They have problems with them in language. So we started again thinking that this rhythmic grouping deficit may be important in characterizing DLD. And I have to plant this because I hope people, when we talk later, we're really excited about some of these non-linguistic tasks, because a huge challenge is evaluating bilingual or very young learners, where they may be having difficulties for such a range of reasons, but if they're having problems with these sequential tasks, maybe that's particularly informative.